Finally, this is the one that's tricky, where people get a little confused sometimes. This is called the right-hand rule with the palm method instead of the British Fleming method there, yeah? So if you like the yo-yo homie way, I'm okay with that. I won't be offended. But I'm not that coordinated. I just like to do the palm method. Here's how it works. Your thumb points in the direction of the charge moving, the velocity. Or another way to think of it is it's the direction that the charge moves, like a proton. Let's think of a proton here. If it's moving, that's like the electric current. So that's easier for some people. Instead of thinking it as velocity, you think of it as current. Your fingers point in the direction of the magnetic field, and then your palm is the direction of the force, like you're pushing it. So some people, they like to memorize it using this mnemonic. To understand magnetic forces and fields, you got to do a little fib. Not like you're lying or anything like that, but F is for force, I is for the direction of current, and B is for the field. Got it? So on test day, I'm totally okay with people writing on their hand. You get a little magnetism tattoo. And it always cracks me up on magnetism test days when I walk by either our classroom or one of the AP physics ones. I always know when people are doing magnetism stuff. You're not crazy, it's just that's how you figure it out. So let's do a simple example here, right? If I have a proton, a positive charge, let's say it's coming out of the screen, this way, it's coming out of the screen, and there's a magnetic field going to the north, it's going to feel a force then, which way? To the what? To the left there, to the west, or whatever, if you want to think of it that way. The best way to learn is by application. So another way to think of the right-hand rule is in real life, we use a right-handed system. If you think about it, we live in a 3D world. So in math, you guys already know this, usually x goes which way? X is to the what? To the right. Which way is y? Y is usually what? Up. And then now we want to go 3D, right? Z. So if you think about it, x, y, z is a right-handed system, where x is your thumb, y is your fingers, z is your palm. So z is going to come which way? Out of the screen, right? So why is this useful? If you're in that pre-engineering class where you do CAD, are you like into computer graphics and all that? You have to think in 3D. So this little simulation is a way to think in 3D. So normally x is to the right, y is up, and then z is coming out of the screen there. And in fact, this is a magnetic field simulator. If I run this here, if I shoot an electron into a magnetic field, z represents a magnetic field. It doesn't get pushed up. It gets pushed sideways. It's like totally bizarre. It ends up going in a circle if you don't change anything. So it's kind of weird there. But anyway, the point is, in real life, we can rotate things. Oh my goodness, crazy! So how do you not get disorientated? How do you keep things consistent? You use a right-handed coordinate system. Let me show you. Let's do an example really quick. Let's be insane. Should we be insane? Let's make x go a different way. Scandalous. Which way should we make x go? Instead of x going to the right, let's turn it. Let's have it go, pick a direction. Oh my goodness, let's have x go, I heard someone say something crazy, down! That's like illegal. That's okay, x is going down. See that? Let's make y go another way. Which way do you want y to go? Let's have y go left. That's nuts. So which way is z? So in order to not get confused or disorientated, so you know which way is up, down, left, right, a right-handed system keeps it consistent. Let's try it. X is which way? Down, right? Y is which way? To the right? Yeah, or to the left? See, I'm all disoriented, right? So which way would z be then? Boom. Z would be what? Z is now into the screen. Okay? So I'm going to do my little tail feather notation like that. Or if I can draw in 3D, which is very hard for me. This requires immense brain power. Ugh. I was trying to draw in 3D into the screen. Ah! You see that? So in other words, we can visualize things in 3D. How do we do this? We had x going which way? Down. Y was this way. And then z was actually... Oh, I actually can't rotate this enough into the screen there. But anyway, it's a way to not lose your orientation in a 3D system.